W equals 4x L minus x A over L squared, you will get P critical equals 8d sub 0 over L squared. So this is actually what he did is guessing. So either he did it by guessing, we don't know how he did. He did not say, that is a method how I obtained. He just said, if you take this and you substitute this, then you will get this. But he didn't, so either he guessed or sat down and tried various things and somehow obtained this. We don't know. Let us just check that that is correct, that this is correct. So this is W, yes? So W equals 4a over L squared xl minus x squared. W prime equals 4a L squared L minus 2x. W double prime equals 4a over L squared minus 2. So then this is EI. I'm substituting here EI. 4d0 over L squared xl minus x squared times second derivative. 4a over L squared minus 2. Then he says plus P critical. 8d0 over L squared. And then W. W is like this. 4d sub 0 over L squared xl minus x squared. So let us check if this is 0 or not. So okay, this 4 times 2 is 8. And this 8 is gone. No, sorry. 4 times 4 is 16 times 32. So this is 32, that is gone. So this d0 and d0 are gone. This L square and L square gone. This L square and L square is gone. XL minus x squared, so this and this are gone. So I forgot here A, because W had A. So this A and A are gone. So that is 0. Everything cancels. So Engesser. The only bad thing here, very small bad thing. Small bad thing. That, okay, EI, said EI equals 4d0x L minus x over L squared. Can I take this page? That means that this function is like this beam is like this. Moment of inertia here is 0. Okay, so maybe not a, I said it's small bad thing. Moment of inertia is 0 at the ends. Okay, so it has a point, so to say, at the ends. Now, okay, so that was Engesser. Then there is someone whose name is Duncan. 1937. That is from England. What he says is as follows. Look, please. If T of x equals, so this is Ex Ix. D is a stiffness. And equals d sub 0, 1 minus 7/3 x over L squared. So that is what he says. If d of x equals this, then W of x equals, so you see he guesses also, 7x over L minus 10x over L cubed plus 3x over L in fifth power. Then P critical equals 60 over 7th d sub 0 over L squared. That is 1937. Also guess. Okay. Do you want us to verify this? Let us verify. So we have this d sub 0, 1 minus 7/3 x over L square. Oh, then we need second derivative of W. So let us deal with second derivative of W. First derivative of W, maybe you will do that. Okay, let us assign homework. Check that Duncan's formula is correct. So, and that was what is a number? 19. No, that is homework assignment 19. So 19.2. You told me that homework assignment number is 19, is it right? Oh, I see, 19.5. Okay, but this actually, this 1, 2, 3, 4 pertains to the same problem. And then part 2 is part 2, verify Duncan's formula by hand. I mean, you don't need maple, etc. I'm not demanding maple, but if you want, you can do it on maple, anywhere. Okay, so that is a very nice formula. Pay an attention, yeah. Yes. Okay, does not have Engesser's bad feature, because E0, I0, for example, equals d sub 0, 1 minus 7/3 0, which is just d0. It does not equal 0. And EL, IL equals d0, 1 minus 7/3. I'm just looking now, and I don't like this, because this guy then is 7/3 is greater than 1, of course. And then we would get negative stiffness, so to say, at L. I should check. Maybe I made a mistake here. Maybe I have a mistake. Okay, in writing this formula. Duncan, let me check. Maybe I'm bringing somewhere else Duncan. Two, 337. Let me check. Yes, I made here a mistake. I have a misprint. That is 3/7. 3/7. Okay. So then there is no, so 1 minus 3/7 will be 4/7 of D0. So then D is not 0. I mean, flexural rigidity is never 0, and it is also never negative. I have a misprint here. I will just pose the following question. So the questions arise on these 3 solutions. By the way, 3 solutions in buckling and no solution for vibrations. For vibrations, no one ever gave any solution for exact natural frequency for inhomogeneous structure. Since Leonhard Euler, he did not do, and no one else did since then. Now, there are many questions, of course. Do you have any questions? Okay, so, okay. Question. Is there a way to tell that the guessed mode were the first ones? Okay, so that is question 1. Any other questions? I'll write down questions. I hope that everyone has one question at least. Mr. Van, your question? Can you speak louder? Yes. Make a comment, please.
In each of these polynomials, and it kind of reflects back to the Galerkin's approach.
I see student says that he saw some non-dimensionality. Non-dimensionality is not necessarily the, I mean, we can always non-dimensionalize any problem, so non-dimensionality is not necessarily the characteristic or not something that would, I mean, any problem can be non-dimensionalized and should be non-dimensionalized. I very much recommend any engineer or graduate student or scientist to non-dimensionalize his problem in order not to make mistakes in dimensions. But let us ask the first question. Let us answer the first question. First question can be answered like this. Look, please. As we said, we don't have exact solutions of this problem. So there is exact solution given. So the question is it first mode or not? So what we have to do is to solve this problem approximately by any means. And then compare the first mode obtained in approximation with this first mode, with this first buckling load. If these two things are close to each other, then naturally we can say that this was the first mode. Or one can say, okay, why don't we solve by finite element method in the computer and obtain several modes? And then if this mode is closest to the first mode, we will say that it was the first mode. But at that time when they did this, whatever they did, say Euler or Engels or Duncan, they did not have chance, so to say, to know whether it was the first mode or not. Maybe only one person, Duncan, could know, because Duncan gave this exact solution when he wrote an article about Galerkin. In 1937, he started to propagate Galerkin method in the West, in England. And there he wanted to compare to check the accuracy of Galerkin method. So therefore, he as if forced himself to invent some problem which has an exact solution. He did not have to, because he could have solved an uniform beam case and compared with uniform beam. He did not have to go into inhomogeneous beam and solve that case. But he, I mean, probably maybe he, was amused with this problem or searched for inhomogeneities before, or maybe he did not succeed in doing something else, had one free evening, and maybe then he did, or he wanted to beautify his paper, and for more beauty of his paper, he put this problem there. We don't know because he did not say. So he had the chance, because he knows already Galerkin method, so he could have used for that problem 2-term, 3-term Galerkin approximations. He was a chairman of Royal Aircraft Establishment, so he had many people underneath him. So he could have asked engineers to do by hand as many terms of approximations. And then he saw that that was probably first mode, and he was happy. That is what I assume. I don't know exactly. Any other questions? Mr. Dale, your question? Okay, for now. Mr. Peguero, no question. Sir? No question. Okay, the most obvious question is not being asked, as usual. And what is the most obvious question? Something that begs itself to be asked. Oh, homework, that is what it begs asking you. Come on, you are too good a guy. Homework is the least important that students would want to ask, but you are a very good student, you want homework, okay? Can you speak louder? We do not, students said whether it is applicable to infinite degrees of freedom or to 1 degree of freedom. So we have a beam. Beam is an infinite degree of freedom system. No, this problem is beam cannot be, so to say, treated as a 1 degree of freedom system. Beam is there is a governing differential equation. I don't know about the concept. I mean, I cannot know concept. I don't know what one can mean by concept and using in one. I don't know. Okay, what is the question that begs itself to be asked? Okay, why don't you think about this and communicate to me? That will be a homework part 3. What is the question that should be asked? Thank you.